The other one is the our text miner. Let's do the same thing. We're just gonna make a new project. Let's just go to the where's our documentation or the text analyzer. I'm gonna make this from the Git repository. Text miner text. No, I'm gonna call it the text analyzer demo. Boom. And so this one, I guess, requires a little bit more thought in some sense, because it's meant to analyze the text data, and we've got vast amounts of text data. So here we do need to think a little bit about how we manage the sort of the data amounts, because there'll be so much data that we can't really fit it into the memory of our computers all at once. So therefore, we actually grab text data using those CSV files as well. Then we put it into actually a formal database, and then we pull information out from that. And here, in order to run something, we'll actually want to run these two scripts first. The create database file, the pre-processed data, and then afterwards we can run the app. You can sort of cheat, and if you set this to true, it's going to Christopher, have you heard of a Parquet file?
Nope.
It's a very efficient way to structure sort of CSV file data, and I do have a very if I were to set this to true, oh yeah, let's try to do that. Then it's going to no, actually let's not do that for now. We're just going to pretend that the only data that exists in the world is the individual CSV files in each of the folders on Amazon. So let's just try to grab some of that, and now we actually have loads of text on there because we pushed all of the Mukteboda text live. So we're just gonna take the first 50 manuscripts that have text available. Slice. You can just probably guess that that's what that does. Just take first 50 for now. All right. I'm just going to run this script. It's going to, and you can sort of see, hopefully there's some nice clear messages being printed out. You can see here we'll be storing text for all the different ones. It adds different columns in our table, in our database. And storing text, and you can see now we grab up to this one, and you'll also see now we actually have a little file here that's called small OCHS db.db. You see that one?
Mm-hmm.
Christopher, have you heard of docdb?
Nope.
It's sort of the new kid on the block for databases. It's just a little bit easier to install and cooler. It's cooler than PostgreSQL. And
just a quick question. Since we in the beginning talked about the structure that is currently based on Google Sheets for metadata, what happens with the metadata in this process here? Is that combined into that?
Here we just ignore we ignore the metadata. The only part we use for the metadata is the catalog ID.
Okay.
And then we just use that so you will actually be able to see what we have put in the let's see, how do I guess now we close the connection. So what we've created now is that I'm just going to, so now we are using this, we just created the files. Okay, now okay, if I just run this, you can see the only table we have is called. Let's see, will this actually do something? All we have created a just take from my word for that that now we have a formal database where, and in this formal database there exists a table called all text, and here's what you can see there's in there. We have the columns internal catalog ID that labels where it came from, and then it just got whatever columns existed in those CSV files with the text data. This also means that there's one thing to think about here in terms of how those CSV files will text generated going forward, because we kind of want transliteration, for example, to be named transliteration. Yeah, we want them to be named in the same way. And of course, I guess, there could have been, maybe there would be a case for, I kind of like the simplicity that there's just a CSV file that you know what it refers to, but yeah, anyway. So the only thing we keep from the internal, the metadata here is the internal catalog ID. And just trust me that there's a vast amount of data in here in this particular table. Now, when I run script number 2 here, I'm just going to pre-process that a little bit, because what you will see here is, if I were to just go and, let me just take the first 10, I'm going to just take the first 6 rows of this, and then let me just, collect here, slice, no, collect will just go and actually get the data. This is just view this, okay. You can see there's a lot of information in each in the transliteration column here. For many tasks, we'll want to do something like count the number of words and so on. So we actually just going to pre-process this and create a couple of additional tables in the database that is pre-processed, such as like where we just have one, where we just split the text into single words and into pairs of words. So that is phrases of 2 words that follow each other. And then we also just want to calculate the frequencies. How often do they occur, just individual words and also sort of phrases of 2 words. And that's going to happen now if I just run this script. So you can still see it's printing out what it's doing. And now that's done. All clear?
Yeah, where's the token list you're using to parsing and saying what are the words you want and which are the words you don't want?
Yeah, so you can see we're just processing the transliteration column, and I'm using so here I'm turning it into single words. So I take whatever is in a transliteration column. So oh, can I make that one work? Oh, I guess I disconnect to the database. Okay, so we just take whatever people have put into this transliteration column, and then we just split it up into single words.
Right, but you don't want simple words, right? You're looking for specific words. So where are the simple words that you're filtering away?
So here I'm not filtering any words away.
Okay, so on and off and all those kind of words would still occur in the database then.
Yes, yeah. When I split it up, I just we can do that downstream on the app that runs. You can actually exclude certain things.
Okay.
But obviously, yeah, you're making a good point in relation to splitting it up into sequences of 2 words, because you probably want this to be the sequence of 2 words here, for example, to be poverty and then whatever this next word is, and not poverty and then a forward slash.
Right.
But yeah. But imagine I just did this splitting up now, and that's all I need to do. And then now I can go into app.r just like before, and I can run this app here. You can see there's actually a public parameters here where at some point I was experimenting with actually connecting to a remote database. But here's our app running. We get a little preview of all the data. what that sort of looks like. I think here I take the first 20 up to the first 20 rows of each of the of 50 of the each of the manuscripts in there. So I can click a little bit around here to get the idea of what kind of data is in there. And then underneath you'll see a word cloud here of the frequency of the individual words. And here, to answer your question, here I can just add things to exclude. Michael, what does ET mean?
I'm trying to remember. I don't remember.
It probably means but or something stupid. So if I write ET here,
So yeah, it's some kind of
now it disappears. There's a lot of single P's in there. All the single P's. Oh, and you can see the counts here and the frequency was to occur. Here you'll see just the words, all the words that are occurring more than 5 times. And here you can sort of see sort of by manuscript. So here I can filter by a single manuscript, and so on. And I can also click this one, multiple words here, and this will show me here's kind of the phrases of 2 words, phrases that occur more than 10 times, and similarly here it is by manuscript. Here's sort of like the top 100 phrases for each manuscript. So I can go and say if I'm really interested in the Hath Pradipika or whatever it might be. I can filter to this. There we go.
So sorry, I couldn't help Googling. Yes. So ET, it means thus this manner, and actually uses to close the quotation. So that's what he said.
There we go.
That's why it's quite
indeed. There's even this really cool function where I can count co-occurrences of words. So maybe I want to count when ET occurs within a range of 5 words from okay, so that just broke. That doesn't work. Oh yeah, I need to okay, there's room for improvement here. So that's how it doesn't work. But I do. Oh God, what did I do? What did I do? What did I break? But anyway, so that's how this works. Yeah. Any questions?
Yeah, I'm just coming back to the filtering of those words. I do understand that you're passing for many things, but I think there's some defaults that certainly would be required to be added there, like the / and all those kinds of things. So I don't know if you can upload that or something.
Yeah, I mean, obviously, you could definitely, you could certainly just do that as kind of as part of the pre-processing steps that maybe you already knew here that you would want to exclude all of those kinds of things.
I think so, but let's get that feedback from Bjarne instead of me.
Yeah, no, but yeah, you're making it's a very good point. Oh, and okay, let's see, and the metadata is not showing up. I see that there's a few bugs that I just need to have to iron out here. But the the point here is just that hopefully the idea is clear that we create a database file here by iterating over stuff online. And then we pre-process it's in some way, just adding some extra tables, and then we run it.
So is this run every time a new information is being added to the database, or when do you run this? Because it would seem we don't need to rerun that very often, right?
Yeah, that's right. Yeah. You would only need to rerun this when you add a new text data that you want to be included. There is sort of like 2, I guess, big obstacles to consider here. I am just going to set, and to illustrate here, if I set this to true, it's actually going to it's going to cheat a little bit. It's going to connect to a Parquet file up on. So if we go to where were our Amazon storage. So if we go to our folder here, you'll see there's a folder called for text mining, and in here you'll see I've actually sort of it's also saved out kind of some snapshots of the doc database. But you'll see this file, all text but the Parquet, that is sort of pre-rendered version of, you see this pretty large. This has got all the text from all the manuscripts we currently have. And let me just process everything. There we go. So locally, I can, well, hopefully I can. Locally, it's possible for me to read in from that and oh, am I storing? Why is it storing everything? I failed to up. Oh, it's trying to. Oh, it's okay. I'm just gonna ignore this. Okay, so to make a long story short, I am just gonna disconnect from this, and I'm just gonna delete these two .db files. Let me just try to redo everything. To make a long story short, online, there's probably a more efficient way to do it than the manner in which I was doing it. And maybe there's a way work around it, but I can run it. I can run things locally. Oh, actually, let's just if I was to just do something with everything here. Okay, we're just gonna create everything here again from scratch. When we deploy, and I think we're just gonna we're just gonna step one step back, and we're actually just gonna go back to the book generator. Book generator. Where's the text? Book generator demo. All right, great. So you might be like, currently, before when we saw the book generator, I was just running it on my own machine. What if I want to expose it to the world? We currently host things on shinyapps.io, because that partly because it makes it very easy. I just click this deploy button here. And this is also kind of why RStudio is pretty nice to work with here. If you don't really have if you don't have a Shiny account, then you'll be prompted to set one up and link to that and so on. But I can literally just maybe I already have 5 apps on my free account. Yeah, okay, I've reached the maximum number of applications in my account. So I'm just gonna kill one of my 5 ones now, because I think the 5th one is probably something that doesn't matter. Where are we? This one button is a very bad application. Oh, I have to archive it before I can delete it. Okay, it's archived, and I'm gonna kill it. Purge images. Clean up. Boom. Okay, so now I should be able to deploy it, and let's call this Ulrich is great. We have a theme here. So you can see here is it asks for which files that should be published with it, and then I click publish. I think I don't actually need to publish this, because that is being regenerated every time I run the app. And you see now it'll go and it'll create a server here. Oh, there we got Ulrich is great. It's on the way. So it's going to create a bundle with those files. It's going to install the right things on the server. It's going to push things up there, and then eventually, when everything runs, it's going to open it up on our server. So to preempt what I'm going to say about the text miner, on the text miner, the full docdb file is quite large, and when I try to deploy this with like the full file with everything in there, the server just crashes instantly. And I think that can be solved by just throwing money at the problem. I think it's just about that one could just deploy it with choosing a paid account and choose an instance with more RAM. But you can run it locally. If you know how to just run the app locally, then you can still just do all of your the text analysis to your heart's content. So for example, now we've actually stored the text for everything locally. Let's also just do the tokenization for everything locally. So this is gonna create a very, you can also see our database is already like half a gigabyte now.
So, Ulrich, what about having individual databases for each of the main documents? Would that make any difference? Because then, at least as I said, you don't really need to create a huge database every time.
So you mean that you just, I guess it's just that, well, you mean for, yeah, that each manuscript will have its own database.
Yeah, and then search across those, or, I was just thinking what, just in terms of how quickly things are being generated and what may be the most efficient approach from a server side.
I don't know. I mean, I feel like so there's a lot of data, but there's not that much data. So you could easily have, so the database itself could easily be loads of megabytes, loads of gigabytes, because it's super quick to just, then it's more about how you query it, and that you don't get too much data back at once when you query it.
Right.
So I don't know whether I was doing I might have just been doing something stupid in the way in which I've actually been querying the database in order for it to crash when I do it when I try to deploy it. But anyway, here you can actually see the book generator again, by the way. But this is you can see that this is now running not on my computer but on the internet. So this is currently available to the entire world at this wonderful address at Ulrich is great at ulrichlinks.shinyapps.io. So if we were to jump back to the text analyzer, we're still in the process of adding bigrams, which is a little bit more of a but even like in the way in which I create these bigrams here, I am using my standard approach from titled text mining. Because that's very easy. So here I actually do this by just doing it for one text at a time instead of trying to do it for everything at once. You could also try to do this, and everything is efficient, which you do directly in SQL. Anyway, I think if I'm able to use local true, use large. Oh no, actually, it's no, it's not so small anymore. Even though it's called small OCHS.db. I think I can run this locally. And I can indeed. So you see, and I'm now looking at 494 unique manuscripts. And I can get all of the frequencies from everything. So someone more clever than me can probably figure out why this crashes the server when I push it live. But in principle, this works in the same way. I can run locally, and then I deploy it by clicking this button, and then I just think about what I want to upload. I'm not actually going to do that here. So you can see this docdb file here is very large, 700 megabytes. But you can see that it works very easily on my computer because I am querying it in an efficient way, because I'm just putting it out from the database. But for some reasons that are not entirely clear to me, it could just be that what 1 gigabyte of memory means that it could, maybe it includes the files that we upload. Sorry, was there anything else on that, Christopher, or is that sufficient?
Yeah, it's fine. Just asking.